Remember that all Kubernetes is ultimately in the service of maintaining containers. And what we're going to talk about next are probes. Now, probes are basically watchdogs that you can put on top of your individual pods and hence your individual containers to basically look out for and enforce certain behavior. The two types of probes that everybody should know about are readiness and liveness probes. Now, the way that both of these probes work is that you start with a container. And what's happening once you place a probe on it is that that probe, represented by this ghost inside of this sheet, is constantly poking that container with a stick. The reason why it's doing that is because every couple of seconds or so, it's going to ask, hey, you okay? And then the container is going to reply back, OMG, yes! And this is going to happen over and over again forever. That's the way that probes work. But the thing is that there's two different kinds of probes, like I said. And here's the difference between the two. If you are working with a liveness probe, when the container is probed by the probe and you get no response back at all, or the response comes too late, what the probe will do is say, well, that's a strike. And after a predetermined number of consecutive strikes, the probe is going to kill the container, ironically enough. That's what a liveness probe is for. Because turning it off and turning it on again is just one of the time-honored techniques of IT troubleshooting. Sometimes restarting the container is exactly what you need. Now, a readiness probe is different. It also is checking to see if the container is responsive, but here's what happens with a readiness probe. It doesn't kill a non-responsive container. This is the gentle parent. It's like, oh, little container Timmy isn't awake and ready to face the day yet. Everybody, leave little Timmy the container alone. All right, he's not ready. I don't want any traffic to go to him. And what's happening is that we are basically removing that pod from any predetermined settings we have that allow other pods or other resources to communicate with it. So putting readiness probes on things makes sure they are ready before they are actually being accessed. Okay, so what do these probes look like inside of manifests? Well, here's a pod that is running a application, simple service. It's a testing tool. And we are adding a liveness probe, which again, notice, is being added at the container level. It's not something you add to a pod. It's something that you add to a container inside of a pod. And I got a lot of different settings here, and this is where working with probes can get tricky. What do these mean? Probes are extremely granular. You get a lot of control over how you want these things to act. Let's start down here on lines 17, 18, and 19. First thing that we need to determine is what is the method of the probe? What's the stick that the probe is using to tap the container? Well, the simple service application here is an API, which means it can actually receive HTTP requests. So the way that we're testing, that we're probing, is that we are sending GET requests to a particular endpoint at a particular port inside of the container. Not all containers are going to handle this particular method of probing. There are lots of different things that you can do, however, so we'll just leave it at that. But what do these other parameters up here mean? Well, initial delay seconds 2 means how soon after creation are we probing? Like, how many seconds are we going to let it get on its feet before we go tap, tap, you okay? 2 seconds. Period seconds. This is asking how often thereafter are we probing. So basically what's happening is that the pod is created, then 2 seconds goes by, and then there is a probe. Then another 5 seconds goes by, and then there's a probe. And then after another 5 seconds, well, you get that. That just repeats forever. So the delay in probes can be significant, because if you're probing all the time, then that makes for a more highly likelihood that you're going to wind up finding an error. Speaking of errors, timeout seconds. How long we giving the container to respond? So after I tap it, tap, tap, you okay? All right. Here I'm saying you've got 1 second to send me back a response to my HTTP GET in this example that you are okay. And failure threshold, what this is saying is how many consecutive, and that is important, consecutive failures before we kill this, not pod, container. Because that is ironically what liveness probes do. They kill containers. All right. And obviously you can tweak these like using all sorts of different parameters, and hopefully that's making it clear. Make sure you're reading the documentation when you are creating probes. And what's super nice is that the difference between writing a liveness probe and a readiness probe is virtually nil. I could leave this exactly as is written, but now the behavior is different. What would happen is that after I get 3 consecutive failures to get a response from this pod, it would turn off traffic. It would turn off traffic to that pod until the probe was satisfied after more probes that, okay, now it's, answering, and now I can allow traffic to go back to it. So make sure you know the difference between readiness and liveness. What I'm about to do is an exercise in futility. It's to teach you that, hey, what I'm doing is great in testing, but is not something you'd want to do in production. And it's also going to introduce a really important concept we're going to be getting into next. Plus, I'm going to show you some cool new kube control commands. Kube control run is a quick and dirty way to create pods without using a manifest. So this is going to make a pod called demo pod. It's going to use the Nginx image inside of it. And a neat command that I can use is port forward. If I use port forward against a pod, which is named demo pod, I can choose a local port, one that's on my local machine, to connect to the container port inside of the Nginx container itself. Now, the container port, that's written in stone. Nginx, its containers are exposed for HTTP on port 80. For local port, it could be any TCP port that's available on your system. I'm going to use port 2224. Now, when I hit enter with that command, it is going to hog up my command line. Now I have tmux, so I'll just split my screen. And by the way, for the exam, tmux is installed, so you will be able to use tricks like this if you are studying this to plan to take the exam. With that port forward activated, look what I can do. I can curl localhost port 2224. What's happening here is that I'm going to the local port that's connected to the container port that's inside of the pod. How cool is this? Welcome to Nginx. This is the HTML. This is literally the welcome page for what's running inside of this container inside of my cluster. You gotta kind of be a nerd to get excited by that, but heck, guilty. Anyway, press Control-C and that'll stop the port forward, and that means that if I were to try to curl localhost 2224 again, I'm gonna get a fail to connect. Now, point is that I want to make a configuration change to how this container works. So there's a couple of different ways you could do this. I'm going to use a kube control exec command. And what I'm going to do is I'm going to open up an interactive terminal inside of my pod, which was called demo pod. And what that terminal is going to be is a bash shell. So I'll just type sh like so. And check it out, my command line has changed. I am inside of my Nginx container right now. And if I needed to make any sort of, configuration changes or things like that, I could. For instance, let's make a, inside of var, let's make a www directory. And inside of that, I'm going to create a new custom index page. So let's just echo help. I'm stuck in a container and I can't get out. That's what I want to be my little welcome page, right? I'm going to put that inside of var www inside of index.html. Now, making that change, you'll wonder, why didn't you use Vim or something like that? Well, where's Vim installed? Not inside of this container. If I try to use Vim or whatever, it's not going to work. So if you are using kubecontrol-exec to open up a shell, just be in mind you're kind of limited to the tools that are inside of that container at the moment. But again, remember, this is an exercise in futility. All right. I'm going to leave that open because I'm going to be using my other command line here to make a change. What I've got is a configuration file here, nginx.config, that will change the way that this container works. What I need to do is get it from here to there. So here's a neat trick. Kubecontrol copy allows you to take local files or files that are remote, that are inside of the pod, and you can copy them in and out. I'm going to go ahead and copy nginx config. I'm going to put that inside of demo pod, and we're going to put that inside of the var www directory. No, excuse me. We're going to put that inside of the etc nginx directory, and that nginx.config file that I'm copying in will replace the one that was already there. So I can confirm that by just checking, hey, inside of the etc nginx directory, is that nginx config file changed? Yeah, all these comments are telling me that that's my custom little file. And what it's going to do is that it's going to use that custom index that I made at var www. All right, this is just showing you like the method behind my madness here. This is not anything that's like super essential to understand how Nginx works. But here's what we have to do. I need to, in order for that to work, reload Nginx. That's going to kick in those changes. So if that worked, we should now be able to do this. I'm going to exit back out and let's run that port forward one more time. Let's do a curl at localhost port 2224. And check it out. I have created an index file that's custom. I created a configuration file that points to it. I made both of those changes inside of my container using some pretty neat kube control commands. Except, achoo! Oh, excuse me. I seem to have deleted my pod. Oops. Well, I could always just remake it, right? Kubecontrol run demo pod. And let's use the image nginx. All right, there we go. Pod's back, just like it was. I can reopen my port forward. I could run my curl command again and... Whoa, what happened? I lost all my work. None of it persisted. All right. This is why this is a, show and not do situation. Great for testing and when you're figuring this stuff out. But the fact that that didn't work is that it is because containers are stateless. All those changes were made to the old container. The old container is dead. It's gone. And the changes that were made with it are dead and gone too. So how are we supposed to take ephemeral things like pods and containers that die constantly, and are we able to push configurations to it? Glad you asked, because that's the next thing we're going to take a look at. All right, let's do a little animation to help make this point clear. So you saw what happened that I made that nginx config file inside of that container. The problem is that when that container and pod go away, it is going to take that file with it. So obviously that's not a solution. We can't have nginx.config inside of the container. Where then? I mean, it's going to have to be somewhere else. In Kubernetes, there exists a type of object known as a config map. This is a whole other type of resource that you can make using a manifest, just like you can make pods. And inside of config maps is where you can put pieces of data, like configuration files or environment variables, or really any sort of thing that you think might need to be changed about how future versions of pods may need to be configured. It makes it super easy to make those changes in a way that's disengaged from the container that you are attempting to adjust. Now, what we're going to be seeing here is that making config maps are very easy. Attaching config maps to containers, that's something of a different story. If you already have experience working with Docker and volumes, great, because this is going to transfer 100%. But if not, no worries, let me explain it to you. The config map, which remember has the config file inside of it, will be mounted as a volume to the pod itself. Once that volume has been mounted to the pod, we then mount the volume to the container. And the volume is mounted to the container at a specific mount point, which is going to be some arbitrary directory inside of the container itself. Now, what's super magical about this is that, remember, you may have many different pods that are all identical, and they all require the same configuration. Well, hey, take that one config map, and you can mount that to as many pods as you want. So configuration changes only need to be made in just one place. That's super advantageous. You're going to be seeing config maps an awful lot. Now, let's see what it would take in order to write a manifest that would actually pull this off. All right, step number one, let's make a config map. As you can see, there's already one config map right here that we don't need to worry about. And we're going to cheat a little bit. We're going to use a kubectl create command in order to make it. First, I need to make a file. Let's create a txt file, heroes.txt. Let's put a couple of my favorite heroes inside of here. All right, Superman, Batman, Wonder Woman, Flash. Yep, looks good. If I were to do a kubectl create config map, or again, if you want to look like a pro, use the shorthand, CM. I'm going to create a config map that I'm going to call dem heroes. Why? I don't know. I'm going to create that config map from the file that I just made, heroes.txt. And bink, there's a new config map in town, dem heroes. Notice data 1 means that there's one piece of data inside of it. Does that mean you can put multiple things inside of one config map? Yes, you can. Do people often do that? No, not really, unless it's environment variables. If I were to run kubectl describe against that particular config map, look at what we see here. The contents of that config file are present just as text inside of the object itself. So you're not putting anything huge inside of config maps. Literally text files are the only thing. Big things like database, that's something about persistent storage, and that's a whole different conversation. Now, let's hop inside of our pod manifest from earlier. Let's not worry about resource control and all that stuff. And let's figure out how are we going to get that config map attached to this pod. Step number 1, we need to add that config map that we made as a volume to this pod. You really got to mind your P's and Q's when it comes to indentation with this, which is why it may be easier just to go to Kubernetes IO, find under the config map page a manifest that already has all this written down. So survival tip for the exam, because you could save yourself a lot of heartache that way. But what you'd see there, and what I'm going to do here, is I'm going to create a section called volumes. That's right under the C in containers under spec. Because remember, this is being added at the pod level. You can add as many volumes as you want. Give the volume whatever name you want, as long as it is unique. Those were all DC characters from earlier, right? So let's name the volume DC Heroes, although I could have called it anything. And what we're putting inside of that volume is a config map. Note the capital M. Boy, let me tell you how many times I've been burned by that. But camel casing is definitely a thing in Kubernetes, and it will bite you if you are not careful. Now, the config map that we created, remember its name is dem heroes. So we're going to put dem heroes right there. So step 1 is complete. We've added the config map as a volume to this pod. Step number 2, we need to add that volume to the container itself. So again, mind your indentation. I'm right here under the I in image, along with everything else that I'm putting inside of that container. I'm adding a section called volume mounts. And the dash, remember, means elements in a list. I could mount multiple volumes to this one container. I'm basically making a list of those. So first, I need to put what is the name of the volume that I'm mounting. Remember how we called it DC Heroes? So make sure that you are capitalizing correctly and doing all that correctly. Boom, done. Next, we need to specify, all right, where in this Nginx container is this volume going to be mounted? That is what we set by the mount path. And what's super cool about mount path is that if you choose a directory that definitely does not exist, heroes, does not exist inside of the Nginx container, as you can well imagine. But with all that done, let's split our screen here and let's create this pod. All right, I need to delete this pod here real quick. And let's make this pod as we see it here. Demo pod is created. Give it a second to come online. All right, I'm going to use kubectl exec to hop inside of that pod, and I want to show you right here. Aha! There's a new directory in town, heroes. So mount path clearly makes these directories if they don't exist. And if I hop inside of the heroes directory, here's where I want you to take a guess. What's going to be inside of that directory? Oh, the mount path's connected to the volume. The volume's connected to the config map. The config map contains a file. The name of that file is heroes. So if you look, check it out. There's all of our heroes. They're showing up inside of the container. And what's super nice is that as long as this config map is up and running, I can delete and recreate this pod all the livelong day. That heroes.txt file will always be there inside of that specific directory inside of my pod. Now, it ain't all sunshine and rainbows when it comes to volumes. Here is a very common mistake. Suppose that I want that file heroes.txt. I want that to show up inside of a specific directory, like inside of a directory that already exists. Let's put it in that Etsy Nginx directory where that nginx.config file is located, right? If I were to really quick delete this pod because I'm going to recreate it here in just a second. Kubectl apply, pod is created, but when I check get pods, womp womp wah, we got an error. What you should be reaching for every time that there's an error, first thing is you're going to want to use your describe. But when we take a look at the description here, it tells us we made the container, but it backed off, restart. It just wasn't successfully able to run. So kubectl describe isn't really helping me here. It's not telling me what's wrong, but this will. Kubectl logs is a cool command that we'll talk more about later that allows you to gather the standard output and the standard error that are generated by containers inside of your cluster. And when I look at this one container pod and the logs that it's got, it's saying, hey, I tried to open nginx.config, but I couldn't. I couldn't find that file or directory. Do you think it's a coincidence that that can't be found when that's the exact directory where we put our volume? No, of course not. Because here's what's happening. Mount paths will overwrite existing directories. And I know what you're saying, because students say it to me all the time. Well, Chad, what if you were to put like heroes.txt at the end of mount path? That would just create a directory called heroes.txt. That would work, but probably not what you're looking to do, because now your file is in a wrong directory. So no, that won't work. It's in circumstances like this that you have to use what's called a subpath. And basically, the way that I would explain a subpath is this. Let me type it out. There you go. Subpath means that instead of like mapping the entire contents of the entire config map to the entire directory etc nginx, let's write a subpath to just a file inside of the config map, which remember, it's called heroes.txt. That's what's inside of our config map. And we want to mount that file to heroes.txt inside of the etc nginx directory. So with that subpath now in place, let's delete our pod here. Let's recreate it. And let's hop inside of it. And let's see if it's working first of all. It is. Looks good. Cube control exec. It's here somewhere. If I hop inside of etc nginx, you can now see that our heroes.txt file is now peacefully coexisting alongside all the other files that are inside of this directory. So use subpath when you need to write to a directory where other files are present, because otherwise it's just going to obliterate the whole thing.